Let's talk about dropping entries from different axes. We'll begin our conversation with a series. So let's create one. And these indices are obviously A through E. And we can simply use this pandas drop method and indicate which index we'd like dropped. And this is going to return for us an altered series without that C index. But if we run series 1 again, we find that the original series has not been altered, and that's because in place is set to false by default in pandas. So either we would have to explicitly set in place to true here, or alternatively we can create a separate variable and save the altered series in a new variable so that we can access it later. So I think we don't need this. Let's run this. And now we have this preserved in a new variable. Obviously we've dropped A and D from here. Drop will work on a data frame just as well as it will on a series. So down here we're creating a data frame. It has 4 rows and 4 columns. We've defined both the rows and the columns. So we have indices in the name of states. We're going to drop 2 of these indexes. We're going to drop New York and Utah. And if I run this, you'll see that it returns a new data frame just with Ohio and Colorado. The drop method also targets the index by default. So I can type index equals here, run this again, and we get the same result. We can run drop on columns as well, but we have to actually explicitly define them as columns here. Recalling once again that our original data frame has not been altered, if we run this, it returns all of our rows but only 2 of our columns. There are alternative ways to approach the column problem. Let me delete this, and we'll put a comma here and say AXIS, our axis, equals 1. And if we run this, we get the same result. You might remember from our NumPy course that the 0 axis is the vertical axis and the 1 axis is the horizontal axis. Let's run our series again so that we can see it as we work on it. And the first thing we want to point out here is that we can access values from our series using numerical indexing, even though these are alphabetical indexes. So let's run this and you'll see what I mean. So this is index 0, index 1, 2, and 3, and we've accessed that value by using a 3 here. Alternatively, we could access it with the numerical index as well, and it returns the same value. Now when slicing labels numerically, the first number is inclusive and the last number is exclusive. So we're getting 0, 1, 2, 3 inclusively, and of course 5 does not exist, so we're getting index 4 here. Let's change this to 2, run this again, and we get index 2 through 4. Let me comment this out and uncomment this. Now we'll run a slice using our alphabetical indices. And here we'll notice that both A and D are inclusive. So the first index referenced in the slice and the second index referenced in the slice, both of them are exclusive. And that's an important distinction to make between numerical indexes and stringed indexes. Now, just as we've seen before, we can not just access values using a slice, we can also set values using a slice. So you can predict here that the B and the C values are going to change to a 12 here. And if we run that, indeed, that's what happens. Indexing data frames is a bit more complex. Let's run our data frame here so that we can explore it as we work. Normally the first request is going to be a reference to the 0 index or the vertical. But here when we're using a label, the first reference is to a column and the second reference is to the row. So let's run this and you'll see what I mean. It's saying from column 2 first, select the value from index 1. So that's why we're getting a 5 back. So here we're not asking for any specific index. We're only asking for columns. We're asking for columns 2 and 4. And so we should get everything back from that. So when we're indexing simply by axes, we're going to see this column first behavior. But when we're indexing by slice, it reverses again back to normal. So this is requesting values from row 0 inclusively through row 2 exclusively. And so you can imagine what we're going to get, Ohio and Colorado.